Hi, today I will talk about how to create Zephyr-based applications and how to debug on Raspberry Pi Pico. The first episode explains how to set up the development environment, so please watch it first if needed. Let's pick a sample application close enough to what we want to do. This time, I need a sample for external GPIO interrupts. Let's check Zephyr sample applications. Basic samples. Let's check button sample source code. Here is the GPIO interrupt config. I will use this sample for my application base. How to make standalone Zephyr-based applications. There are three types of applications. Applications in Zephyr project /Zephyr folder called as Zephyr repository applications. Applications in Zephyr projects folder called as Zephyr workspace applications. Applications outside of Zephyr project folder called as Zephyr freestanding applications. This time I will use freestanding application. Let's start by copying the button sample folder. Please don't use spaces for folder names, otherwise it will not work. First I will try to compile for Nucleo board, because button sample does work with no change. According to documentation, we need to set some environment variables, but don't rush, we will fix this later. Temporarily, I will run Zephyr environment script. With this, environment variables last until terminal closes. Successfully compiled. Let's set up standalone Zephyr application on VS Code. Open the project folder we just copied in VS Code. Delete build folder. Let's add Zephyr environment variables to VS Code. With this, environment variables are added to VS Code's terminal. Create a new folder named .vscode. And create a file name settings.json inside of it. And put the environment variables here. Then reopen the VS Code and try to compile. Successfully compiled. Let's set our board name. Open the CMake list file and add this line. Let's try to build without board option. We have compile error because Raspberry Pi Pico board doesn't have switch. Let's add switch 0. For this, we will use app overlay file. Let's check switch 0 definition in Nucleo board's device overlay file. Let's create a new app.overlay file and put what we need in it. In my circuit, the switch connected to GPIO28. I will show the schematic later. Let's try to compile. Voila! Our binary file is located in build/Zephyr folder. For more about west command, please check the docs. How to debug. For on-chip debugging, we need some hardware and software. Let's prepare one by one. First, hardware. I will use PicoProp for hardware debugger interface. Let's get the compiled binary for PicoProp and flash the Raspberry Pi Pico. Download the UEF2 file for PicoProbe. Put the Raspberry Pi Pico into bootloader mode by pushing boot cell button while plugging to your computer. Then copy the UEF2 file to your Pico storage. Building OpenOCD. Currently, OpenOCD does not officially support the PicoProbe, so we need to build a specific version of OpenOCD. Since this is a Pico-specific version of OpenOCD, you don't need to run make install. We will add OpenOCD's paths to VS Code later. Installing ARM tools. Let's check the tools we have installed. VS Code settings. First, install Cortex debug extension. Open settings.json file and add OpenOCD binary path. Create a new file named launch.json inside of .vscode folder and add all these settings. This is the schematic for my setup. Hardware debugger interface on the left and target board with the button on the right. Let's start debugging. Let's add some breakpoints. Do not forget to compile before debugging. Then click the Run and Debug icon on the left, and click Start Debugging. Voila! Let's check with the serial terminal to see Zephyr console output. Let's push the button and check the console output. Awesome! In the next episode, I will talk about real-world application with Zephyr OS. Please check the video description for codes, links, etc. I hope you find this video interesting. Please let me know what you think in comments. Please consider like, share, subscribe and click the bell button. Thanks for watching.